Oh, Dunkin' Donuts? Anyway, don't forget to get your, where is the nearest Dunkin' Donuts? Missoula? Is there one in Missoula? No Kalispell though?
I'm feeling proud.
Krispy Kreme doesn't have the official Charlie D'Amelio drink, bro. What are you doing? Get with the program.
Really?
Okay. So yesterday we did this one. So real quick recap of that. It had x equals 2, x equals -2. It had x equals 1 asymptote. It had x over x n behavior, x over x squared n behavior. So that tells you that the n behavior looks like this. All that information combined lets you graph it. Okay, and then I was asking you guys to think about once you analyze 22, what are some connections you can draw between these two graphs? Because they are reciprocals of each other. Yeah, the x-intercepts of this guy become the So there's some simple transformations that we've studied. Like for example, multiplying a function by -1. When you do that, you preserve the x-intercepts. If you just flip a function over, you preserve the x-intercepts, and you, for example, the y-intercepts would become the opposite of what they used to be. This transformation is complicated enough that like we don't really study it because it's not something that you can just easily visualize like the other ones. But let me say this. Ask yourself if this makes sense, if this statement makes sense. The x-intercept on this guy is now the vertical asymptote on this guy. Ooh, think about that. Because before, plugging in 1 made the top 0, thus it was an x-intercept. But on this one, since it got flipped over, 1 makes it a division by 0, so thus a vertical asymptote. Conversely, x or a vertical asymptote on the original graph, right? Those happened at 2 and -2 because those two values make the bottom 0. Well, now they make the top 0, so they're actually x-intercepts now. You feel okay about that? So there's another connection. So on a pair of reciprocal functions, this guy's vertical asymptote values are this guy's x-intercept values, and vice versa. How about y-intercept? This guy's y-intercept was 1/4, 0.014. What's this guy's y-intercept? 4. So there's one of the only, I don't know, do you see what I mean? They're a reciprocal relationship. So this guy's y-intercept is the reciprocal value of this guy's y-intercept because the functions are reciprocals. So put that in there. It's not to scale, it's fine. Let's call that 4. This is -2, this is +2. Then end behavior, this guy. End behavior. Well, you've got, let's say if x is big. So if x is big, then my function is basically y equals what?
X.
How do we feel about that?
Lovely.
Huh? Lovely. Yeah. Because if x was big, you cover up the non-dominant terms and you have x squared divided by x, right? Which is x. So what you can say is that for large enough x values, really big positive values or really big negative values, either one, your function is going to look very close to a y equals x. We know what y equals x looks like. So we know that long term it looks like this, and long term on the left it looks like this. Okay, so let's put that all together. So if you put all that into one graph, you get something like this. You see how the end behavior is in there? There's that left end behavior. There's that right end behavior. Are there any horizontal asymptotes?
No.
There's a diagonal asymptote. There's a vertical asymptote. But there is not a horizontal asymptote. All right. Feel good about that, guys? Cool beans. Finished it.
You totally intended to get full of excited, but
Yeah.
$23. Has anyone ever gotten a 23andMe test? You guys?
I thought
It's
like a movie about
It's
a dog.
ancestry, it's like ancestry.com.
Oh no.
Well, hold on. I don't think it's like Ancestry.com unless they send you something and you spit into this vial.
Yeah, they both do.
That's what Ancestry does? Okay. I guess Ancestry expanded its.
You can't like drink water.
Definitely.
Ancestry, you can't drink water before you do it. It's weird.
Anyway, so they analyze your genome and tell you some information. I don't know. I've never. Has anyone, who's done that? You done that? Or to tell you?
I'm Scandinavian, Egyptian, English, Italian. Steps.
Cool.
Yeah.
There's a great part in Bill Bryson's book, A Short History of Nearly Everything, where he presents an argument for why you pick almost any like really famous person, and you are related to them. Most likely, you're related to them in some like not a super far removed way. Like, so Napoleon. And Napoleon's probably like here. What's Rita?
Dynamite.
No, not Napoleon Dynamite. No. Never mind. What's the first thing we should do with this function? We should factor the bottom because you can factor it. It's going to probably give us some more information. They both have an x in them. Factor that out. So you have x plus 2. So, let's get the domain. Domain. X cannot be what? It can't be 0. It can't be -2. And what exactly is going to happen to those two x values? Well, we're going to have vertical asymptotes. We're all cool with that, right?
Yeah.
Sweet. Sure there's no questions? Let's get the x-intercepts or singular x-intercept. And then the let's look at the y-intercept. This one, other classes reeling on this one. Very good, yes, exactly, there isn't one. All right, Alyssa, what's a good argument why there's no
Because
y-intercept?
you can't, so if you plug in 0 for all the x's, it'd be -1/0, and that's not possible.
Fantastic explanation. Good. Yeah, right here we said x can't be 0. So go to try to plug in 0, and you're like, well, you can't. So there can't be a y-intercept. Let's do the end behavior. End behavior. Who's dominant on top? X. Who's dominant on bottom? So if I simplify that, yeah, so I have 1 over x type end behavior. We know what that looks like. So that means that this function is going to approach 0. I like this approach because it gives you an extra piece of information. Not only do you know it's approaching 0, but you know it's approaching 0 from the top on the right side. It's approaching 0 from the bottom on the left side. So it tells you. So as x approaches infinity, y approaches 0, If x approaches negative infinity, y also approaches. Okay. So hopefully each one of those individual steps is, at this point, pretty straightforward for you. Just to recap, domain, you look at the bottom of the fraction. What x values make the bottom 0? Those domain restrictions typically just translate into vertical asymptotes. Your x-intercepts, you look at the top of the fraction. What x value makes the top of my fraction 0? For the y-intercept, you plug in 0. In this case, we couldn't do that. Okay, graph time. Here's a vertical asymptote at 0. Here's a vertical asymptote at -2. I drew my graph kind of crappy, sorry. I didn't give myself very much room over here. Let me try again. Zero. My x-intercept was at 1, 0. Okay. What do we think? Anyone got a piece of insight to move us along?
The end behavior.
Yeah, let's put the end behavior in. So that has to be true and that has to be true. So I might as well put that in. It's a good idea. Very smart. I can even complete this one right now because it's not like I can pass through the x-axis, right? Because there's no x-intercept there, so we can't pass through it. So that means I have to just do something like this. Make sense to everyone? Yeah. And then here, I kind of have two options. I either have to pass through and go down, like that. I can maybe imagine bouncing off there, but how do I know it doesn't bounce off? Yeah, this term that generates the x-intercept, this x minus 1, is not like, if it had been x minus 1 in parentheses squared, then I'd probably have a bounce at 1, but I don't. What's another really concrete way to confirm this? Does anyone have an idea? Huh? I already got the end behavior. Right now I'm wondering, how do I know it doesn't just bounce off here and go to positive infinity? What could I do? It's really simple. Yes, plug in an x value between 0 and 1. We don't really care about the exact number, but if I plug in like a half here, I'd have a negative, positive, positive, which is a negative number, right? So what I showed there is if I plug in a 1/2 x value, I'd get a negative y value. You can extend that logic out to, it's not hard to go, okay, well, that's also true for any number I pick between 0 and 1, would produce a negative y value. All right, are we done? There's a big old no man's land in the middle here, but my domain says x can be any number except for 0 and -2. So there's got to be stuff living in here. It's got to be part of the curve. Again, let's just reuse that same method. If I plug in -1, will I have a positive y value or a negative y value? Let's see, plug in -1, we get negative, negative, positive. So that's positive. Does that make sense to everyone? Sure. Just to clarify, I'd have a negative number divided by a negative number, which is positive. The other way to reason that out is to look at each term that produced the asymptotes. And again, those terms, that's not x squared, that's not x plus 2 squared. So since they're single, these all have a degree of 1, so their asymptotes are going to move in opposite directions. If you had like an x plus 2 squared, then you might have this kind of behavior happening. Yes. Okay. Any questions on end? No. Okay. One more example. One more. This is your request, right? 24? Okay. All right. Look at 24. While I'm erasing here, think 24, I believe, is the first one that we've done with this feature, unless I'm mistaken. So I'm asking you, look, what makes 24 a little bit different than every other question we've done? There's no x on top of the fraction. Yes, very good. There's no x on top of the fraction. 24. Now, what can we do to the bottom of this one? Factor it. X plus 2 and x minus 2. So, domain. X can't be -2, and it can't be +1. That's going to turn into vertical asymptotes of x equals -2 and x equals +1. This will be an interesting question. X-intercepts.
There is none.
Oh, very good. It's very fast. There isn't. There aren't any. Let's pause there. Think about that. All right, Sarita, give us our reasoning there. Why? How come you're so sure there's no x-intercepts?
Because nothing can make y equal 0 because there's no x on top.
It's a pretty good explanation. But I take it a little bit farther to say because there's no x on top, there's no way we can make the top be 0, right? Usually there's an x up there, so by choosing some x value that works, we can make the top 0, but there's nothing you can possibly pick as your x value that's going to make that be 0. So, everyone okay with that? Question?
Wouldn't the domain be x can't equal?
Thank you. Yes. Thank you for pointing that out. Yes, x cannot be -2, it cannot be 1.
Just keeping you on your toes.
Yes. All right, y-intercept. I know the first number. Second number is, what's the y value? -1/2. Very good. Excellente. Again, you just plug in 0 for x.
Would you plug it in at like the original problem or?
Either one.
The original function.
Yeah, the original one. If I look at the original function, I can even just cover up the x's with my finger and see that it's 1/-2. But certainly it's not wrong to plug it in here. There are equivalent functions. Let's get the end behavior. Let's see. This has end behavior like 1/what? So that tells me that the end behavior is going to be like the 1/x² parent function. So that is good information to have. It tells me that it's going to approach 0 from the top on the right and approach 0 from the top on the left. It's going to do both. Okay. So yeah, I still can write x is approaching infinity, y is approaching 0. We still write this. That's the exact same statement you write for like the last function we did, but we also know now that it's approaching 0 from the top on both sides. By the way, what's a concise way of writing this whole statement here?
Horizontal asymptote.
Very good. Horizontal asymptote. We say there's a horizontal asymptote of y equals 0. By the way, did the last problem have a horizontal asymptote? Number 23 did. It was y equals 0. By the way, did we pass through the horizontal asymptote?
Yes.
Because that's nothing wrong with that. Remember, the horizontal asymptote is just an expression of the end behavior. It just tells us what's happening on the very far right side and the very far left side of the graph. Doesn't tell us anything about what's happening in the middle. All right. Graphy time. So we got -2. +1.
Is it vertical asymptotes?
What else can I put on there? Intercept. That's all we have, but this is the best part of this end behavior argument. Is I've already got 2/3.
I'm sorry.
2/3 of the information we've already got because of the end behavior. Since we know it's approaching 0 from the top on both sides, we can just go straight to having that. Having that. So that was a nice time saver there. And then here, what can we not do? Can I do this?
No.
No, we can't cross into the x-axis. We've established there are no x-intercepts. The only thing that makes any sense is to have our graph do something like that. Now, could the top of the hump be on the left or the right? I'm not really sure. If I had to guess, I'd probably guess it's on the left, but that's just a guess. We're not really too concerned with that. We could ask that question taking calculus. That'd be an interesting question to ask. When does that hump actually occur? Where does it occur? All right, so yeah, there you go. Notice it never touched the x-axis at any point. All right, that's it for the video today. That's 3 examples for you.